All right, so I have 12 o'clock, so I do think I'm going to get started again. Just a brief introduction. Josh Kamps, Regional Crops and Soils Educator with Extension. I cover Jefferson, Rock, and Walworth counties. I've been with Extension since 2018. Started in the southwest part of the state, Grant, Green, Iowa, Lafayette counties, and then moved with my wife and our dog to Janesville, so closer to my wife's family here in Rock County and serving this area now. Today we're going to talk about crop staging, stand counts, and soil and tissue sampling. So hopefully we can keep some interest in this talk, in this discussion, build this out a little bit more. And we'll have a chance during our three in-person trainings later this summer, if you are able to attend those, where we can really go to the field and practice some of these skills there. Okay, so I see a few more names are coming in as I was introducing myself. So again, Josh Camps with Extension, we'll get started here. All right, so while you're finishing up with that outline, or excuse me, with that demographic survey, just a little bit about what we're going to talk about today. I'm going to actually start with some stand counts, give you some basic information on, taking that stand count as our crops are, starting to emerge or even, getting into some of those different growth stages. That is the next topic then is doing some crop staging for corn, soybean, and then I included wheat as well. What stage of growth is that crop in? There's some important reasons why we want to learn that skill. It's one that we'll use then just kind of without a lot of thought as we're entering fields, in the future. We'll be able to kind of do a quick assessment, what stage that crop is at to help with some decision making for the operator. And then we're going to end with a conversation about soil sampling and tissue sampling and why we might, excuse me, how we kind of do those processes in the field, and then some different timings that we might utilize that. So to begin with stand counts, it's as simple as it sounds. We actually are, counting, getting an idea on that that crop stand in the field. So how many plants are in a certain field, the density of those plants across that acre of land. It might, help with us assessing that crop's yield potential. There's obviously a lot of factors, with a crop that is just emerged that's going to impact the yield potential of that crop. But the amount of plants, in a given area of the field, so the amount of plants per acre, is one of those main factors. Okay, those are the reproductive sources in the field. Those are the little factories in the field. So, we have a goal and we set the corn planter or the soybean planter up. And how close do we meet that goal is really what some of this initial work is. So this might be, a project that you as a crop scout would undertake when are going to some of these fields early on, is getting an idea of that stand density, how many plants are in a field per acre. It might also aid with making some replant decisions. So if a crop stand is not adequate, if we don't think we're going to be able to reach a yield potential goal that the grower has, it might become a time when they want to plant a different crop or replant the same crop to try to get a higher yield potential in that crop. And then there are some tools that we might use. I have them broken out here by these three titles: a traditional method, a hoop method, or a camera method. Okay, so you'll need to have some basic information when you're going to the field to take these stand counts. And really, it's going to go back to how we're measuring 1/1000th of an acre. Okay, so it depends on the row width. You can see I have a table there that's out of one of our replanting guides that Dr. Joe Lauer had put together. But this is that basic information. So if we know the row width of the crop, we measure that length, and that gives us 1/1000th of an acre. Okay, so kind of that standard corn planting width is 30 inches. So that would mean we have to measure a row length of 17 feet 5 inches, count all the plants in that area, and then take that times 1,000. That'll be our planting density for that spot in the field. Um, Here's another example. This is more in line with what our soybean planting width is. Okay, so again, you can see 30 inches there is 17 feet 5 inches, but then it goes down from there. Another popular width would be 15 inches. So that's twice the row length. All right, to get to that same one thousandth of an acre. So as we narrow our rows, we often, have a little bit greater spacing between the seeds. So that's why we need to measure a little bit longer area to get a better reflection of what that entire area in the field is. Okay, a different way to think about it is to use some type of a measured area. So like a hula hoop, for instance, is what this type of tool is. Some type of circular, object that is pretty uniform, so that we can have a diameter across. And then we have a factor. So, for instance, if you have a hula hoop or some type of a ring with a diameter of 21 inches, that factor then is 18,119. So what that means is we're going to count all those plants within that ring, all right? And then we're going to come back to this chart and multiply it by that factor. All right, so it's a different way to do that density, that plant density across the field. It may work, for the crops that you're looking at. It may work better to just do that row count. But another tool that I wanted to share, and this chart is available actually in the Purdue publication. But if you want to take a screenshot, this is all public information that once you kind of have this chart, then it works for when you're out in the field. Another method that may be of interest is this camera method. Um, the Cool Bean Lab at UW-Madison has, worked with some of the computer technology people on campus and has come up with what is called the Bean Cam. Okay, so it's an app. I have a screenshot there of what it looks like at our integrated pest and crop management site. So you can download that, with iPhone or iPad, or if you have an Android tool. The link there is there as well, and I see it just got added to the chat. But the way this is set up is we take 5 pictures. I have a little example for you there on the right-hand side of the screen. Field, I put a name up there, Johnson 2 is the name of the field, and I have those 5 different sample pictures that were taken. And it gives me an average. There's some calibration instructions there for how you might want to set that. What I ended up with for estimated population was just under 100,000 plants. Put in the date, that I was in the field taking that. This was last year. I actually was looking at a field that had some slug damage to the soybean plants. It gives you a recommended, fill-in rate of how many seeds you might want to add. But then what's interesting is the research that Sean Conley's lab and others across the country have done is, what is the potential of reaching our maximum yield with the current stand we have, and then also, with adding additional seeds to the field. All right, so you can see both of those stands are at 100% of yield goal. So it really wouldn't make sense to add any additional, bean seeds to that field, since we were able to meet that goal with the stand that we had. All right, so a little bit extra information there maybe than what you'll be collecting, but it's another tool that it might work out. If you have a smartphone with you It might be a kind of a quick way to do that across the field. Maybe compare that to one of those other methods and kind of see how is it working for you in the conditions that you have. Okay, and a little bit about small grains. A lot of those decisions have already been made, but I thought it was important to include it. It's something that I think we do every spring. If we plant a small grain crop, did it over winter? Is it a good enough stand? Sometimes we do that from the window, from the windshield, right? But there's reasons to get out in the field, and with your work, that's one of your main goals is to give that good advice to the growers that you're serving to help them know, where are they at with their plant stand. So here's the steps. I took this snapshot out of the wheat visual guide. That's at the IPMC website. But we want to count the number of plants in a 3 foot length. We want to do this in three areas across the field. Take the average of those counts, multiply that number by 4, then divide by the row width in inches. Okay, so here's an example on the right-hand side for you. We have those three counted areas. They ended up with 40, 35, and 45 plants each. Divided that by 3 for an average of 40. Multiplied by that factor of 4 to get 160, and divided back by the row width, so 7.5, kind of a standard drill width. So we got 21 plants per square foot. Okay, and some information on the right-hand side that you might use or your supervisor might use. This is through, again, Sean Conley's research at UW-Madison with that, plants per square foot. Okay, what is that goal that we need to reach our yield goal? Um, Less than 12 plants, Sean says automatic replant. 12 to 15 plants, maybe consider replant depending on current economic situation, for that small grain crop versus planting another crop. 15 to 22 plants, you got a chance of meeting your yield goal. There's some other things that need to come into play, maybe the amount of tillers that we have, per plant. And then if we're at that 22 plants, we should have that full yield potential for the crop for that year. Okay, I guess I'll pause there for just a half second, and see if there's any questions about crop stands, why we take them. Did I gloss over something too fast? Do you have another technique? I On the last slide, I can go back there. I think 2 slides ago, I did throw in a little line there about taking a drone image. And some of that work has been evaluated. If our software is calibrated right that we're using, I think it can work. It might be a way, to get out over a larger fields, save a few steps. But again, just making sure that that work has been evaluated, back to more of those hand type counts, is a way that we really can be confident then that's going to work. All right, and I did see a question that came in to the chat. Open that up real quick. Question is, what's the ideal stand count for rye to take to harvest? That is a really good question. I am going to default to the same stand count that we used for wheat. Okay, and so if we can meet those goals, I do think it within Sean's uh, small grains guideline, there's a little bit in the very end that talks about some of our other small grains, barley, triticale, rye, and such. Um, and all those plants are a little bit different and their stand density. So yeah, I'm gonna default to that for right now, and maybe one of my colleagues that is on, if they know that answer, they want to put that in the chat, or I will follow up afterwards to get a more exact answer for you. Thank you for the question. Okay, now getting into that crop's growth stage, knowing this for your field matters because why does it matter? Well, I have a few reasons here that I wanted to include. There probably are a few others, but we're gonna start with these for today. So thinking about corn and soybeans, even some of our small grains, our herbicide guidelines are very specific for what growth stage those crops can be in. All right, so if you think about what a herbicide does, it is a product that is inhibiting the growth and actually killing a plant. All right, so when we spray that, oftentimes we spray it on the target plant, but also on our crop plants at the same time, right? So we're expecting our crop plant to metabolize that herbicide while we are, um, expecting that weed plant to take in that herbicide and cause death. All right. Well, they all are a little bit different, but the goal, right, is that we're going to kill that plant. They all affect different, growth points within a plant, different herbicide modes of action. So with that, knowing that crop stage where the crop can metabolize that herbicide and not have an impact on further growth and development is important. We don't want to cause stress to a plant at a time when it is starting to think about the yield goal that it wants to have for that year. Another reason might be monitoring that crop's growth and development. If we have a crop that we want, ready for harvest at a certain time, if we are curious, how our crop is developing, for maybe putting on another application of fertilizer, it's important to know what that growth stage of the crop is. And then one of the other important areas is meeting that timing for a fungicide application. Um, our plant pathologist, Damon Smith, has done a lot of work looking at timing of fungicides for multiple types of plants. Okay, we're going to talk about a little bit of that today, but understanding what that growth stage is so that we can time that fungicide to protect, that developing plant, protect either the seed head, protect those leaves towards the top of maybe the corn canopy, protect that flower um, during development of the seed pod and soybean. Those are some reasons, why we need to understand the growth stages to make those recommendations. Okay, so beginning growth stage is germination. I thought it was important to include this. Some of our crops are still in this stage, right? The ones that haven't emerged yet. So we're going to start with corn. Think about germination, that first step where the seed imbibes oxygen and water. That radicle emerges and moves downward. The coleoptile emerges and moves upward, and then later those lateral roots will, start to grow away from the mesocotyl. All right, so a couple good pictures here from the corn guide at UW-Madison, so that we can kind of understand what that looks like underneath the surface of the soil. Corn growth staging, though, is really based off of the leaf collars. Okay, so to have a growth stage further than you had last time, you need to have that entire leaf collar, right? So you can see that on this corn plant on the right-hand side, where that leaf, it'd be that first true leaf, where that comes down to the stem, it forms that full collar around the stem. And you can see that on the second leaf as well, second leaf collar. Not included in this picture would be, most likely the third leaf. That does not have a fully developed collar. Okay, so it doesn't completely fit around the stem of the corn plant. So we can't give it that extra growth stage. So this would be a V2 or in the second growth stage. All right. And then on the left-hand side of this screen, I have just another image there that shows that germination and development of that early corn seedling. That very first leaf is going to be the true leaf. It's going to have kind of a rounded tip on it, but where that meets the stem, that is considered the first collar. Okay, another representation of this from a guide from University at Purdue. You can see that going up the plant a little bit farther there in the picture on the right. That true leaf at the bottom, that's at leaf collar 1 or V1. As you go up the plant, you have V2, V3. That fourth collar is just hardly fully formed, but that would be a V4. And then our fifth collar, our fifth plant or leaf is not fully emerged yet, so we can't give that next growth stage. So that would be a V4 corn plant. All right, so if everything's attached well, this is pretty easy to identify once you kind of get an eye for it. Once you know that you're looking for that leaf, but it has to come all the way back to the stem and form that collar. Okay, so corn has vegetative stages from VE, which is the emergent stage, all the way up until VT, which is tassel. Okay, some important stages when yield potential is being determined, V6 through V11. Okay, so when we have that sixth collar on the plant, that's when we're starting to determine the amount of rows that are on the cob. Okay, and a little bit of an interesting fact, kind of a fun fact. Kernel corn ear rows are always going to be even, numbered. Okay, so it has to do with the anatomy of the corn plant. So we're going to be 12, 14, 16, 18, maybe even 20. Um, those rows, the amount of rows really has an impact on yield, and that is going to be uh, determined through that V6 to V11 time frame. All right, so we're thinking about trying to reduce stress to the corn plant at that time. Uh, you know, hopefully we have some of our uh, herbicide applications, done before that corn is actually starting to canopy at that point. Hopefully have our soil fertility, adjusted at that point, so we can let that corn crop develop. And then from V12 to VT, the number of kernels per row and that ear size are being determined. Okay, so another timing when we want to try to avoid, stress to that corn plant. If we have the ability to put some irrigation water on, if it's dry, that might be reasons to consider that, kind of during those time frames. Another interesting piece about the corn anatomy is that every corn plant has a different amount of leaves. Okay, so it's somewhat based off of the relative maturity of a corn plant, but it's also based off of that growing geography of the plant. So, for instance, maybe 110 to 115 day relative maturity corn plant might have 21 to 23 leaves. Okay, so that'll actually have a V21, a V22, a V23, and then that VT is that final vegetative growth stage. Whereas maybe a shorter maturity corn plant in northern Wisconsin, for instance, would maybe only get to V17. Okay, before it gets to that VT or that tassel timing. So there's not a definite number of leaves. It can be based off of the growing conditions, based off of the genetics of that corn plant and in that environment that it's growing in. Okay, so this will be a little challenging to describe here virtually, but I wanted to share it anyway. Hopefully, when we get in person here in later June, this will be a really good skill that we can learn when we're in the field. But there's a couple of growth staging methods for if we're in a field that's missing, that really nice, beautiful bottom true leaf and collar, and we can just count those all the way up. There's a process here where we can kind of go back in and do some further investigation to say, okay, what growth stage is this plant? We actually have to go down to the base layer, to the soil, and kind of pull back a little bit of soil there and start to identify some structures on that corn plant. So we want to look for a stem node that's right at the surface of the soil. This little chart I have up has a star next to representative plant. We'll see that in a couple of slides, but that just means, looking at picking a plant that, meets kind of that representative goal across the field. Not picking kind of an outlier plant. So it's called the six leaf method. So first we kind of clear out that space by the surface of the soil and we're looking for that node. I think this picture does a pretty good job of kind of showing that bulge or that node on that corn plant. This node is typically that sixth stem node. Okay, so that gives us a little bit of an idea of how far along this plant is. If we've lost those bottom leaves. So maybe they were eaten off by insect damage. Maybe they dried and fell off. Who knows what happened to them? But if those leaves aren't there anymore, this method will help us better understand what that growth stage is. Okay, so you might need to take a knife and kind of open that just a little bit and expose it so we can, kind of see for sure what we're looking at on that stem node. And then once we have that identified, then we can count up from there. Okay, so we know that that is our six leaf collar, for instance. Then we can go up from there and keep adding leaf collars until we run out of them, till we get to those newer leaves. So that'll give us, that corn stage of that plant. And again, that little asterisk there, 50% or more of the plants in the field are at or beyond, the size of that plant is what you want to try to measure. Okay, a little kind of confusing, but hopefully, again, in person, we'll be able to explain this just a little bit more. Another way is actually to look at that plant, from the root up. So corn staging, that intermode method. So we're going to dig a representative plant, actually split it open with a pocket knife. Okay, and we want to try to look at those root nodes. Right, that's going to give us an idea of the age and the development of that plant. So identify that fifth stem node. Okay, that's kind of the more uh, dominant looking one there, kind of towards the top. The internode between the fourth and the fifth usually has a little bit of a kind of a gap there. That might be a way that kind of show that to us. We can kind of count either way. And then count upward from that fifth stem node, okay, to determine that highest visible leaf collar. So again, we want to try to, pick uniform plants, that have the right developments for getting a gauge on that entire field. Right, so we'll take a look at both that six node method and the internode method in person. Hopefully between now and then your fields that you scout will just have perfect leaf structure and you'll be able to find that first collar and work your way up from there. Or again, reach out or ask some questions afterwards. We can talk through it some more. A little bit more about corn growth staging once we get into that reproductive stage. Another important check-in point is that pollination. Okay, so there's a little bit of a trick here. Um, Granted, every ear of corn is important to your growers, but it's important too to know what that pollination level is. So a little bit of a trick here. You can remove an ear carefully. Pull the husk back. Um, from that ear. You kind of want to wait till that pollen shed has stopped, maybe 2 to 3 days. Once you've carefully pulled those husks back, and you can shake that ear. Okay. Any of the silks that fall off, that's a good sign that they actually pollinated, so that little ovule was actually fertilized. If the silks are going to stay on there and retain on there well, then that's kind of a sign that those kernels did not become fertilized and they will not develop any further. Okay, so a way to get an idea on that pollination, across the field, um, as one of the more important stages of corn production. Reproductive stages are from R1 to R6. A corn plant actually is in a VT and an R1 stage simultaneously during pollination. All right, that the tassel is producing that pollen while we have our ear development in the R1 stage accepting that pollen. And then that really critical stress period of time, 14 days before and 14 days after R1. So it kind of catches some of those later V time frames, vegetative time frames, and then into that R1 time frame as well. Trying to avoid crop stress again at that point. Okay, finishing up on corn, um, the six reproductive stages. I think it's interesting that once we hit that silking or we hit that tassel timing, we really can start to predict when that crop is going to be at maturity. So I think it's important as you're scouting those fields to kind of mark some of those timings down in case the grower has questions. Later on, hey, when did that field tassel? When did that field start to silk? That can give us some pretty good guidelines here based off of the research data that we have. It'll be roughly this many days before that corn reaches that black layer stage. Okay, and the black layer is that physiological maturity stage of corn. When it starts to dry down, it isn't taking any more nutrients in, and moisture isn't leaving back into the stem, so that crop is starting to dry down. Okay, and a look at this maybe from like a corn silage standpoint. Okay, looking at the ear and how those kernels look, R1 through R6. Kind of an important fact as well is we really, need to wait until that corn kernel, that corn ear has developed and reached about that half milk layer. You can see how the total dry matter, how it just explodes from early R5, where it's at 45% dry matter, up to that mid R5, where it's at 90% of total dry matter. Okay, so really a lot of um, extra yield, I guess I'll say, for that silage crop if we can allow that to dry just a little bit more in the field. Again, follow all, you're a little bit too much information maybe for some of your work here this year, but some interesting information as you build out your skills moving forward. Okay, a little bit on soybeans. Um, Pick the pace up a little bit. So again, they go through that germination process. The imbibes water, the radicle forms, the hypocotyl elongates. But it's a different plant, right? So it's not going to push that stem out like the corn plant does. It's actually trying to lift that entire, seed up to the surface of the soil so those cotyledons can open up and form the first leaves. Okay, there's a couple of methods here for doing that soybean growth staging. I just wanted to kind of share that within Sean's guide that I pulled all these snapshots out of. He talks about the difference between kind of the node method and the leaf method or that trifoliate leaf method. Okay, so growth staging field, we want to take, into account different places within the field. The recommendation here is to pick 5 different areas. I think that's a pretty good number on the low end. If you can pick a few more, I think that's fine. But determine the growth stage of those areas. Pick at least 10 plants in each area. And make a little bit of a chart. Is it at V3? Is it at V4? What growth stage are those plants at? And that can help give you a field average. I think a good technique for when we're doing other crops as well. Have some type of a table set up and keep track and try to get that average from across the field. Here's what some of those early growth stages look like for soybeans. So on the left is that emergent stage. Okay, that cotyledon is hitting the surface of the soil and opening up, and that growing point is there. That VC is that first unifoliate leaves. Okay, so that next step right after the cotyledon, you can see there's the first leaf node is present at that time, but it has not reached the leaf stage yet until a full trifoliate opens. Okay, so this is actually V1 soybean. So we have those cotyledon leaves down at the very bottom. You can see those. We have that first leaf node. where those first true leaves opened up. And then we have our second leaf node followed by those trifoliate leaves, which makes this a V1 plant. Okay, and there's some other information there. Again, this is all within that soybean growth guide. Some really good information, presented in a way that I think is pretty straightforward to understand. V2, we have some of those similar, you know, features there with the different leaf nodes, but then we have that second full trifoliate that's open. V3 is, again, has the first trifoliate, the second trifoliate, and if we work our way up that stem, then that third trifoliate opens up. Okay, hits that V3 growth stage. Again, important to know if we're putting different herbicide products out in the field, these early growth stages for both corn and soybean, are those plants going to be able to take in that herbicide and metabolize it and not cause injury to the plant? And I have the dot, dot, dot after V3 because we learned that a corn plant can have different vegetative growth stages. Soybean plants are the same. They actually can have almost infinite number of vegetative growth stages. And there's a lot of reasons why. But anyway, we can't really put a true count on that. It's V3 to whenever the plants start to flower. Okay, and that's at this R1 stage. All right, and this is one of those first stages where, if there's been some white mold risk, in that field, or if maybe we have a soybean variety that is susceptible to white mold, this would be one of those first timings that we may consider a fungicide application. Again, utilize some of those tools uh, that Damon Smith, our plant pathologist, has put together. He has some tools for both soybean and corn that help us gauge, are the weather conditions right for needing a fungicide application. We might have the plant in the field. We might have um, the plant at the right stage. We might have the disease risk, but if the weather conditions aren't there, we may not, see that disease risk in our fields. Damon always talks about that as being the disease triangle. So we'll learn more about that in future talks. Um, V2 simply means that there is there's more open flower nodes, on those plants, and flowering continues. It's based off of day length and whether the plants, have a determinate growth type or indeterminate growth type. V3, the next growth stage there, it actually, is one of those later reproductive growth stages as far as, us being able to really put out any type of a crop protectant, on those plants to help reduce that risk of that white mold um, spores, getting into the flower and affecting the development of the soybeans. So just kind of knowing our window is kind of that R1 to R3, which can be length of time is not definite, but that's kind of our window to protect that soybean seed, that soybean yield in our field from white mold. Just a picture I thought was interesting looking at that development of the seed pod, through more of those later stages, R3 through R6. Okay, and a little bit on wheat. So some spring management, which we already took care of this year. We're pretty much past that. That green up is that Feeks 3 or Feeks 4. Okay, so oftentimes, like our wheat that's planted on time will actually reach a Feeks 3 in the fall, before winter, before it goes through the vernalization period. So when it starts to wake up or green up in the spring, it's going to already be at Feeks 3 pretty much, and hits Feeks 4 pretty soon. So that's a good timing for doing one of those stand counts, a good timing for nitrogen application, and a good timing to be thinking about any weed control that we might need in the field. Okay, so there's some further study that we can learn about the amount of tillers on a wheat plant. This picture I thought showed that pretty well. We have that main shoot, so that's that main plant that came from the seed that we planted last fall. but then these tillers have developed. Tillers in small grains are a positive. Tillers in corn are maybe not really a positive. Okay, we want that corn plant to focus on that one stem and maybe one or two ears. We want this wheat plant, though, actually, the tillers help us. Those are extra growth points, extra places for yield to develop on that plant. So there's some things to think about, not just the amount of plants, but the amount of tillers that are on the plants as well can maybe affect our stand counts for small grains. Um, this V5 or not V5, excuse me, this Feeks 5 point is when that head is starting to push up through the stem. It's a point when that plant becomes a little bit it becomes risky to do, many herbicide applications. It becomes risky to drive on the field very much. So you want to try to have, any of that work done ahead of time, so that we don't injure that plant because it actually won't be able to grow back, from injury when it's at this Feeks 5 stage, since that head is starting to actually emerge above ground and get up into that growing stem of the plant. Sorry, wrong way. And again, you can open up that stem of the plant and you can see these different growing nodes. Okay, it's kind of an interesting way to see, where that head is actually at and those different growing nodes. Feeks 8 is a flag leaf stage. May or may not, be reason to think about a foliar fungicide. It really depends on the year. Um, you know, if you're helping to advise some of that, connect with our specialists at UW-Madison, be looking for some of that information. This isn't an every year kind of recommendation, but this is kind of that timing to protect that flag leaf, which really helps with the yield potential of that small grain plant. Did it again. Okay. And then one of the more important growth stages, though, in wheat is this fusarium head blight stage, okay, or this Feekst 10.5. So that's really the stage when the flowers start to come out of that head. And this is common for, for other small grains as well. We have kind of a small window, that 5 to 7 days from when that flowering begins, when we can put a fungicide product out there to help protect that plant from fusarium head blight. So something that, to talk with our growers and to have them be aware of that the window is kind of small, but this is a research type window that we know we can really make an advantage to the quality of the grain if we can hit this timing right. Okay, I'm going to skip the last stage there. It just talks about that kernel, that physiological maturity of that wheat kernel, and then the dry down that happens. All right, a little bit about soil sampling. I can see I maybe haven't left myself enough time. So I apologize if you were mostly here for the soil sampling part. Um, but this may be something that you're still doing in a few fields, maybe growers that have picked up some new acres for this year. Or maybe you're just going in because it didn't get sampled last fall and you want to get a sample this spring. All right, so we want to sample to 3/4 the depth of tillage. So if we're planting like a 9-inch chisel plow depth, that'd be like 6 3/4 inches as your sampling depth. No-till, kind of that 6 to 7 inches is the recommended depth. Okay, so kind of get yourself calibrated, know where that depth is on your soil, um, soil probe, so that we're sampling to the right depth. And just a little note, if we are kind of curious or think our soil pH might not be quite in line in no-till, we want to take that 0 to 2 sample there to get a more accurate pH sample. But we want to take 10 cores equal 1 sample. Okay, so 10 pushes of the soil core into the ground. 5 acres max per soil sample. You can sample less, if you want to sample more frequently. And then they'll collect those samples from representative locations in the field. So for instance, on the right-hand side here of the slide, there's a 15-acre field. We're kind of sampling, we broke that up into 3 kind of general areas, and we're sampling, 10 times across each of those 3 areas. So we're going to collect, 30 sample cores. Those are in three different samples. And we might, this might be one field though. Okay. So you're going to have three soil samples for one field. But if it's all managed the same, when we fill that out in that soil um, submission form, we'll get an average, we'll get a combined result for the entire field, which is normally how we make the recommendations then for the next 4 years. Okay, so that routine soil test, this is a sample sheet for UW-Madison for the soil and forage lab. Work with whatever lab is convenient in your part of the state. Fill out the submission form as accurately as possible. If you do so, the some recommendations will be given back, and these are the same recommendations that you'd get through A2809, which is our soil sample or our soil application guidelines for Wisconsin. The same information that's within the SNAP Plus program, and really the information that we want to be giving growers as crop consultants, that really um, meet that spot between, meeting our yield goals, but also not causing, extra nutrients being placed in the landscape. Okay, so those profitable fertility recommendations is what you're going to be getting back. We need to include the soil name, the crop rotation, the yield goal for that crop, any legume or manure credits that are present in that field. Those are all information pieces that will help us get the most accurate fertility recommendation back from the soil lab. Soil nitrate tests, you may be, doing some of those here pre-plant or pre-side dress. So these are a couple of soil nitrate tests that are available. It has its own form. Uh, so, make sure you print that out separate or have that available when you're taking those samples. You'll need the field ID, sample number, some crop information, soil name, soil organic matter, manure application history for the PPNT. Not as much for the PSNT. Okay. That is just field ID and that sample number. Use something that, gives you or gives the grower or your manager, the information they need then to get back to that right field. Figure out what you want to call those fields, sample numbers, something that works for you. Um, for the PPNT, we actually are going to collect a 0 to 1 foot sample and then a 1 to 2 foot sample. All right, so you may need a specialized soil probe, that you can extend down deeper into that soil profile. We'll want to collect 15 cores from a field area up to 20 acres in size. Okay, so that means 15 soil cores 0 to 1 and 15 soil cores 1 to 2 foot. If you're really feeling ambitious, you can collect 2 to 3 foot soil cores. Usually we don't recommend that just for the amount of extra effort that it takes. And that can be estimated at the lab. Okay, so if we have a good sample of 0 to 1 foot and a good sample of 1 to 2 foot, we can then estimate the nitrate content in the 2 to 3 foot portion of the soil. We'll want to sample in the spring ahead of any nitrogen application. And on the right hand side, it just kind of talks about how we use that information to make a recommendation. We're not going to talk about that today, but it will be within the slide set that you'll have access to. Pre-side dress nitrate test. So a little different timing here. We're sampling at that V3 to V5 growth stage. Okay, so another, I guess, reason to kind of know what our growth stages are is for our fertility application and the sampling. Again, 15 cores from across the field area up to 20 acres in size. So if your field is 10 acres, you can still pull 15 cores. If your field is 40 acres, you're going to want to pull two separate samples. Okay. Sampling depth, though, is just 0 to 1 foot and sample between the corn rows. Okay, so this is getting an idea. So we might have put some fertilizer out already early, or we put some manure out early. This is getting an idea of what's been broken down through the soil organic matter through the nitrogen cycle and is available now to our growing crop. A little bit about tissue sampling. And again, I apologize. We kind of have to rush through this a little bit, but we'll have a chance at the in-person meeting to talk about this more. Reasons for maybe taking a plant tissue test, gauge the level of crop nutrient uptake, confirm a nutrient deficiency, diagnose a nutrient imbalance. If you suspect a nutrient deficiency when you're pulling these tissue samples, it is a um, recommended approach to also pull a routine soil sample at the same time. Okay, so within a similar area of the field. Gives us a chance to, better understand, is this deficiency we're finding in that growing plant part of lack of not having those nutrients available, or is there something within the plant that's not allowing them to be taken up right? And this is a chart that is within every plant tissue sampling form. It's usually on the backhand side, but it just gives us an idea of what part of that plant we need to sample. Okay, so for instance, for corn that is 12 inches, which they really should have a growth stage there. But anyway, 12 inches is probably that V4 to V5 stage. Um, we want to actually sample the entire plant and sample 10 to 15 plants. Okay, so again, every plant is important to the grower. But if it is, the goal of getting some plant tissue analysis, we do have to sacrifice a few plants for the betterment of the field. Apologize. Okay, and this is the submission form, what it looks like for the plant tissue test at the Wisconsin lab. Again, it might be different at other labs, but contact information, payment information, sample ID, crop name, stage of growth, plant part, field appearance, and then was a complimentary soil sample submitted. Okay, just some basic information that you're going to want to have. Okay, resources and just a couple slides here are left. Again, some of this has been shared out during the talk. I do suspect we'll have a pool of resources that we'll put together that will be available at the in-person trainings. Um, you know, a, a big set of information that can be for you to have. A few credits here where I grabbed some of the snapshots and such, some of the graphs for my talk. One thing that I wanted to just share, I guess, as we finish up for today is that, really think about that soil sampling or plant tissue sampling ahead of time. It makes a lot of sense if you can sit down, at the office before you head out, or wait in the truck before you head out, and get all of your soil sample bags labeled. Know what size the fields are you're headed to, so you know how many sample bags to prepare and bring. Throw a few extras in. Um, Occasionally something happens where a bag will rip open, or maybe there's a bag that has an issue to begin with. But have those labeled ahead of time, labeled in the way that works best for you with your manager's guidance, works best for the grower, because that really is important work that you're doing. It's hard work, and important work, and having that labeled well can really help when you get that data back to be able to connect that back to certain fields. With that, thank you for attending. Um, we'll look for another inch of rain maybe next week around Tuesday night, Wednesday morning, so you can join us again next week. And I'll stay on if there's any other questions. If I miss some in the chat and you wanna talk some, I will hang on. Thank you for your time and attention.